All right, hey guys, I'm going to take you through the Chapter 12 Stoichiometry Note Outline Part 2. If you see a chart there with boxes, I think that I'm actually just going to upload a separate, really short explanation on those boxes, maybe a video right below this on Google Classroom. So I'm taking you through that Part 2. You have the notes attached, so just follow along with me. Throughout this video, I may tell you to pause so that you can do some of the work on your own. That might be really helpful for you. So this is all about stoichiometric calculations. All we're doing is converting things. So in order to do some conversions, we need to be able to do three basic things. So in order to do conversion in stoichiometry, we must, one, balance the equation, which we know how to do. We have to, two, find the mole ratios, which we learned in our previous section if you watched the previous video. And then we have to do our mass to mole conversions, which is just finding molar mass. Okay, that's all we're doing. We know how to do molar mass. We know how to do all of these things. So this is not a hard skill, but it's sometimes hard to know what to do first kind of thing, okay? So here's the first example I'm going to walk through, and this is where I'm going to start asking that you pause and do it yourself. So number 7 on our note outline says, example A, potassium reacts with water to produce potassium hydroxide and hydrogen gas. How many moles of hydrogen gas are produced when 0.4 moles of potassium is used up? Complete the problem below as I walk you through it. So the first thing we have to do is to balance the equation. So go ahead and pause me here. All right, if you balance the equation, you should have ended up with something like this, right? So this is all balanced. We can move on to our next step, which is we need to find the appropriate mole ratio, okay? This is where it can get a little tricky. How do we know which mole ratio to use? Well, we're looking at what we have and what we need. The question asks how many moles of hydrogen gas, so this is our first thing in our mole ratio, are produced when 0.4 moles of potassium are used up. So we're looking at potassium and we're looking at hydrogen. So the mole ratio we're using is 1 mole of hydrogen per 2 moles of potassium. So for every 1 mole of hydrogen we have 2 moles of potassium, or we could say it backwards. For every 2 moles of potassium we have 1 mole of hydrogen gas. Okay, so we found that mole ratio. The next thing that we need to do is do the mole to mole conversion. So all we have to do is set up with what we have. So what do we have? Well, we have 0.4 moles of potassium. Well, what do we want? We want to know how many moles of hydrogen are produced. So what do we have to do? We have to use our mole ratio, placing our mole ratio here, in order for the moles of potassium to cancel out and for us to get the moles of hydrogen up top. So moles of hydrogen is going to go up top. And how many moles of hydrogen do we have in our equation? Well, we have 1. So it'll be 1 mole of hydrogen. On the bottom, our moles of potassium will go on the bottom, right? Because we want moles of potassium, K, to cross off. How many moles of potassium do we have? We have 2 moles of potassium. We'll put that down on the bottom. Okay. We do the simple math. 0.4 times 1 divided by 2. We get 0.2 moles of hydrogen. That's really simple. All we had to do was use our mole ratio to come up with that solution. Here are 2 more examples, example B and example C. Okay. All we're doing there is finding the mole ratio. And then we're converting from moles to moles, which is a really easy conversion. Okay. Now we can do moles to mass. This is example D, and this is number 8. Number 8 says potassium reacts with water to produce blah, blah, blah. It's the same reaction. How many grams of hydrogen gas are produced when 1.25 moles of potassium is used up? So we need to balance the equation first. We know how to do this. We need to find the mole ratio. We're going from grams of hydrogen, so we've got hydrogen here, we're going from moles of potassium to grams of hydrogen. So we've got hydrogen here and we've got potassium here, okay? What do we have? We have 1.25 moles of potassium. What do we want to get to? We want to get to grams of hydrogen. We cannot go from moles of one substance to grams of another substance. Okay, we need to go from moles of potassium to moles of hydrogen, and then from moles of hydrogen to grams of hydrogen. So how do we do that? We have to set up our mole ratio here. We want moles of potassium to cancel out, so we're going to put moles of potassium on the bottom. And we want moles of hydrogen, so we're going to put moles of hydrogen up top. And how do we get these numbers? Well, these are the coefficients in our equation, okay? How do we get to grams? Well, we know the molar mass of a mole of hydrogen. So in 1 mole of hydrogen, how many grams are there? Well, that's something that we had to find. So you find the molar mass of hydrogen. Okay, those things cancel out. In 1 mole of hydrogen, we want to convert to grams. So how many grams is in 1 mole of hydrogen? Well, we know it's 2.016 grams. So our moles of hydrogen cancel out, and we end up with grams of hydrogen. Now, you should recognize this from Chapter 2 conversions, right? Okay, now we could do some simple math. 1.25 times 1 times 2.016 divided by 2. We get 1.26 grams of hydrogen. So how many grams of hydrogen gas are produced when 1.25 moles of potassium are used up? It's going to be 1.26 grams of hydrogen. That's how much we would predict. These are all mole to mass conversions, okay? And here are some more examples if you'd like to do those. Then we have mass to mass conversions. So same problem here. We want to balance it. We balance it. We want to convert to moles first. We cannot do anything in these types of reactions or these problems without first converting to moles. So what do we have? We have 25 grams of potassium. We're going to go ahead and put that up top. We have 25 grams of potassium. We want to convert it to moles. So if we want to convert to moles, moles is going to go up top, right? Okay. Well, if 1 mole goes up top, how many grams is in 1 mole? Well, 39.099 grams of potassium is in 1 mole of potassium. We're going to do some simple math here. We find that 25 grams of potassium is equal to about 0.6394 moles of potassium. Now that we have that, we can use our mole ratio, right? What mole ratio are we using? The same one. Okay. What do we have? We have our amount of moles from here. 25 grams of potassium is equal to 0.6394 moles of potassium. We want to use our mole ratio. So moles potassium is going to go on the bottom. We're looking for hydrogen, so hydrogen is going to go up top. We don't want moles of hydrogen, we want grams of hydrogen. So we cross that off. Our moles of hydrogen is going to go on the bottom, so moles of hydrogen will cross off. And how many grams is in 1 mole of hydrogen? Well, we know it's 2.016. That crosses off. We do simple math here, and we find that 25 grams of potassium is used up and 0.6445 grams of hydrogen gas are produced. Okay, that's going from mass to mass conversions, and this is as hard as it gets. There's 2 more examples there, H and J. Okay. I'll do my best to put the answers to these other examples online for you. Okay. If you have questions, I'll be in Zoom every week, Monday, Wednesday, Friday at 1:30, just hanging out and waiting for your questions. If you don't come there, then I'll just be sitting there staring at the screen. So don't let me sit there bored. Okay. Hope you guys are doing well. Wash your hands. Love you guys. Bye.